Yeah. This is how hacking looks like. Yeah. Hi, my name is Emil, and I'm a Swedish hacker. And I was here last year, hacking some e-commerce. This year, we'll hack some other stuff. But at Security Fest, there were some rules when hacking with 0 days. Do you remember? Nah, me neither. I think it was more like guidelines than actual rules anyway. It was something about hospitals, but it was nothing about banks. Not a single word about banks, actually. They did shoot me with a Nerf gun mid-presentation, and I have seen some today. Enough about that. What is practical exploitation? For me, it's to perform and execute the full chain, not in a lab environment, but rather in the real world against real targets. From finding a vulnerability and understanding how to exploit it, to write the exploit, use the exploit to deliver a payload with a practical, real use case. That's practical exploitation for me. So let's leave the lab environment for a moment and talk a little bit about my background. I started out my security career at the wrong side of security. When I was younger, I was in this hacking group with just a few people. I did some bad stuff. I mean fun stuff. And educational stuff. And I learned a lot. So, for practical exploitation, vulnerable patterns is key. Especially repeatable vulnerable patterns. Let me just show you what I mean with a quick example to which we can all relate. This is a streaming provider. They provide streams behind a paywall, or so they think. And if we are able to hack them, we might also be able to identify some patterns that we can reuse to hack other streaming providers with much less effort than doing the initial research. So that's the kind of pattern we're looking for. And if I just open Developer Console and inspect the Network tab, I can see that they're using a CDN to deliver static assets. If I reload it, I will have every one of them. If I also have internet connection. And we can see they are using a very specific CDN called Bunny CDN. It's this one, and it's a CDN for which I have prior knowledge already. I know they are working with video streaming solutions for video delivery and video on-demand solutions. And also I know their specification. And the specification for the CDN is not specific to this streaming provider. And if I just hit the search button, and I search for my favorite team, I can pick the one in the list, and I can scroll down, and I can see that there are currently no live or coming events. However, there are some in the archive. And I can filter the requests for my search, and I should be able to bring up the response for the broadcasts, if I can find the right one. So the response is just a JSON blob that populates the application. And if I'd like to see this stream, I can filter for it. And I get some information about a broadcast. I don't get the stream, obviously, but I get some metadata, and I get some information. Among that, I get the broadcast ID. I can copy it for later. And if I click this one, I'm just presented with a login screen. Hence, the stream is behind a paywall. This is actually all information I need to watch the streams for free. If I go back here, I can make this a little bit bigger for you. I can cat this one and explain how it works just real quick. So this is their CDN, the Bunny CDN, and they have some pull zones, and they have some pull zones matching the blobs. And we are supposed to ask the CDN for what broadcast ID do we want to watch. And we can do it like this. We can add in the broadcast ID, and note that there is no guessing involved here. This is all according to specification. But we also need to tell the CDN from where or from what point in time do we want to see the stream. And an HLS stream or an HTTP live stream, according to RFC, also according to specification, starts at 0 and is delivered with a transport stream, not TypeScript, obviously. And we can just curl for it. There is no brute forcing, there is no authentication bypass, there is not even a header spoofing involved. And I can just open this one up. Maybe not. Do I have internet? I'll open it from my offline files for now. And I am presented with a blue background. And why is that? Well, I'm not logged in, obviously. No, that's not why. I was presented a blue screen because the first 6 seconds of the stream is just a blue background. According to RFC, let me double check this, cat CDN2 text. I think it looks right. I am supposed to just be able to curl a CDN. And if I type 100 here instead of a 0, that's equivalent of fast forwarding 600 seconds into the stream. That's 10 minutes. And I think I could not download this one either. Is it my VPN? Let's open that one from the offline files as well. And I am able to see parts of the stream, or the entire stream, without logging in. Soon it is up. So, my point I'm trying to make is not that I can hack this streaming provider, because it's not important. What's more important is the pattern. If this streaming provider is providing their streams for free on a free CDN, there might be other streaming providers providing their streams for free at free CDNs. And that's a pattern that we can search for, and we can exploit, or we can hack other streaming providers with much less effort than doing the initial research. Now, when we all agree on the concept of vulnerable patterns, let's have a look at another pattern that is of a little bit more use for the average malware developer. Earlier this year, I was at another conference called HackCon in Oslo, and I was presenting a 0-day, and I was presenting a 0-day in some old software that still has plenty of installations, and I was presenting an unauthenticated remote code execution exploit. And I'm not walking you through that one today, but we will open it up and see if we can find such a patterns in the vulnerability that we might be able to use today to find remote code execution elsewhere. And I will open this one up in a custom hacking tool called the Explorer, and this software is called Image Clipboard. So this tool has 3 main areas, and one is populated right now. And it lets me view the application from outside. So the left area says to me, from where can I poke the application? By poking, I just mean sending requests. And I can see if authentication is required or not. So I can see that we have some AJAX callbacks. We have some that requires authentication and some that does not require authentication. And if I select one, let me do this a little bit smaller so we can see everything at once. A little bit more, like that. You don't have to be able to read the code. I will not. But let's just have a look at the hacking tool. The second area at the top, it's populated with content now. And it will let me know how to poke the application to access this endpoint. So if I send a post request to the AJAX endpoint with an action called cb_images_save, the application will run a callback called save_images, and it will do so without me having to authenticate. The third area, it will let me know what happens behind the scenes inside the application when the application is poked in this very specific way. So this is now my entry point to the application, and I can see what code is running when I poke the application this way. This is not presented to me as regular PHP. This is, well, of course it's regular PHP, but it's not presented to me with the regular PHP developers syntax highlight. So without reading the code, I can use more of a software or security researcher's highlight so that I can just watch the colors before I read the code. So at least on my screen, I got some feedback last year that the coloring is not perfect. But this is shiny pink, this one, and this one. And it means I can inject stuff at these points. So shiny pink means user control input or hacker control input. So I can immediately see that at this entry point, I can inject stuff into the code, and I can also see I have some shiny orange on my screen. Shiny orange means it's a dangerous sync. So without reading the code, but just looking at the colors, I can see that I can inject stuff into something dangerous. I also have a red portion down here, and red means dead end. I cannot get past the die, or at least not easily. So it's perfect for me when exploiting this, that the dead end is at the bottom. If the dead end were present somewhere here, it would be harder for me to exploit. So somewhere between the entry point and the sink, we do not want any dead ends. And this is something we can take note of and create a pattern. One, thank you. So we need to poke the application, and we need to poke the application without authentication. And we can do so by hitting AJAX endpoints, by hitting REST APIs, or by having direct access of some sort. Let's add the condition that we want the callback that does not require authentication to have a dangerous sync, preferably inside the callback, and that we want it to take user input. Oops. Input. So these are now two dangerous conditions, if we can find this in the same code base. But let's add the third one. No dead ends, preferably no dead ends between the entry point and the sink. And we can search for this. And every time we hit something that matches these three conditions, we expect to see something similar or of similar structure that we have on the left that we are used to hack already. Let me show how this works. Is it big enough? Yes. So we can do so with another custom tool. We can actually not just search through a single code base, we can search through entire repositories. In this case, we're searching through the entire official WordPress repository of hundreds of thousands of projects. And we can tell the walker that no auth, unauth, please. We want unauthenticated endpoints. And we want to filter, if I can type, filter the sinks. And that we filter the sink for something that we are used to hack. Like the one on the left is a remote code execution via arbitrary file upload. Let's make it easy for us and filter the sink. Whoops, let me do it like this, you can see it. Move, uploaded file, file, put, contents, and maybe add F, right. And let's just walk down the current directory. So the current directory is just a small subset of the real repository. It's about 1,000 projects. And they were selected based off the installation count and the update frequency. So any project in this list has somewhere between 20,000 and 30,000 active installations. I can just kill this, we don't have to wait for it. But for each hit in the list, when searching for these three conditions, we expect to find something similar or exactly the same as what we already have on the left side. We expect to see the exact same structure, but we expect to find a similar or a slightly different problem. The problem we have to solve is always of the structure that we need to inject something. What we inject needs to travel down the path, and it needs to hit the sink, and while it hits the sink, it needs to evaluate to something executable. And if we can do that, we have remote code execution. Let's go back here. Let's pick one. Let's pick this one. See if we have this one. If you have seen any of my previous talks, you know that I am crawling basically the entire internet for website statistics. Let's double. And a great side effect of that is that I can search through my local index really, really fast if I would like to know what software runs on what domains. Let's pick 50. So this is now a list of 50 domains running the software that we are investigating, so that we know that it's worth the time. Also, did I say that? Cut that part out. If you're doing security research, this is 50 potential clients. Let's put this in domains.txt, save them for later. Now, let's open this one. Maybe use this. I hope my internet is working now, because my plan is to download the latest version. Downloads. No. So I'm not sure why my curl is not working, but I have it offline. So let's just copy it for now. And let's unzip it. And let's open it with the Explorer. So on the left side, I have all possible entry points to this application, and I'm not really interested in authenticated ones. This software is no longer maintained, and it has a previous security issue with not as high severity as the one we are investigating. And that is gold for the malware developer. It means they will have no more updates. Let's see if I can find. This is why. This is the security issue that is known. A hacker can inject a URL. It is run through base 64 encode, and it's sent back with a response. And if you're an exploit creator, you immediately see that you can use this to leak some information on the server. If you're a webmaster, maybe you don't care. I think this is the one. So this is the one matching our search criteria, and this is where we look for remote code execution. We know from the tool that if we send a post request to the Ajax endpoint with an action of udraw designer save page data, it will run save page data as the callback, and we can see that no authentication will be required following this path. So we enter the application from here, and we can start reading the code, or we can start looking at the colors, and we can see that we can inject a lot of stuff here. From this point in time, during execution, I control everything that is marked in pink from this point in time and during the entire execution of the application. But we can also see that we have some marked in orange down here. That's our dangerous sink. And the problem we need to solve is that something that we are injecting needs to be executable while hitting the fwrite. And we can see that the second parameter to fwrite has some pink to it. That means there will not really be a problem injecting executable code The problem will be having the code executing. Because we can control this parameter, it's sent through base64 decode, and it's sent as the second parameter to fwrite, and that's just the content. However, we have the first parameter, says XML handle, and we can see they are expecting an XML file. XML handle is declared like this, goes through fopen, it's derived from output dir, and that is based on the output path, which we can control, and output dir is created here. It is then concatenated with a directory separator and an XML variable, and then the XML variable is just the document name and some pagination. So the document name, we can inject it. We can type whatever we want here, but it is passed through the native PHP base name, and they are having .xml as the second parameter. They are enforcing the XML extension, and if we upload a file that is called something.xml, it doesn't matter if we can inject PHP to the file, because the web server will not execute it. And this is now the problem that we have to solve in order to gain remote code execution. So let me ask you a question. If you immediately see the solution to this problem, if you could join me on stage right now and tell the audience how to solve this problem, please raise your hand. Okay, so there are no hands in the air. Guess I have to do it myself then. A guess? Yes, please. No, it's not a null byte. I'm sorry, it's a great guess, but it's not a null byte. However, obviously I'm telling you how to do it. Let's just start. I'll just show you, actually. I'll put this at the side for reference, and the fact that no one did raise their hand doesn't mean no one can solve the problem. It's actually not that hard of a problem, and it will be very easy as I am explaining it to you. Otherwise, I wouldn't have picked this problem to show for an audience in the first place. So let me just put this at the side and have as a reference while we bring up our hacking framework on the right side. So on the left side, I have the code that I'm trying to hack, so I can view it. And on the right side, I have my hacking framework. In my case, it's HackWP. You can choose whatever hacking framework you prefer. But I'll just start by making a directory for my exploit, and I'll just call it udraw. And I will copy the template exploit from HackWP training 1.0 arbitrary file upload, because that's what we're going for. And I'll copy that to my directory, and I will call it 340 arbitrary file upload, because that's the most recent version of the software. Let me open that one. And let me delete some stuff that we don't need. This is just a comment. Let me rename it. udraw arbitrary file upload. We have to tell the framework that we're working with a plugin. We have to tell the framework what's the slug, udraw. And we have to tell it that we can hack any version up to and including 340. We tell the framework it's arbitrary file upload. We delete the rest of this. Let's keep the options as is. It's just a file name. It tells the framework that we are letting the operator of the hacking framework to set a file name of their choosing. And if they don't, it will be payload.php. And from now on, we are focusing on the exploit method, which is here. And actually, it's just the code between these two lines. Let me create the lines and make this a little bit smaller so that we can view it, something like that. So somewhere between this line and this line, and I will delete the stuff that we don't need. So our exploit will be between these two lines. This is just error handling for the framework, and you don't have to to concentrate on that right now. Let's concentrate on the exploit. Let's put in the endpoint. And we can reach it without authentication despite the name, and we know that from earlier. We have to send some data to it. Let's declare it like this. And let's copy the action. And let's put in the template. And now I'll just put in the stuff that I can inject. I'll put everything from here into my exploit. Output path. Let's spell this properly. Asset path. Document. Page number. And page data. And let's align this. Something like that. And let's just put uploads here. So /uploads is a known directory on any WordPress installations that is accessible and writable by the web server. That's what we need here. We don't really need the asset path because we remember from earlier that our XML handle is based on the output path and that the document is the file name we're trying to upload, and we are deriving it from the framework. So we just put the variable name file name. And let's just put the page number of 1. And the page data is sent through base64 decode on this side, which means on this side I'll pass it through self base64 encode. And I should be able to have any PHP I want here. Let's just have hello. And then there is one more thing we need to update. Let's scroll down this. We can see it says response. So we have to update the success logic to take response instead. We can delete the path. We don't need this part. Let's just have file uploaded. And let's tell the framework in what location we're uploading the file. So self.target is decided by the framework operator, which today is me. And then we are placing the file in WP content, uploads from above, and then we set file name from the framework. And if I didn't screw this up, we should be able to at least run it and try it out. So we start the framework in interactive mode, and we can see that we have all our exploits on the left side. We can scroll through them, and we have all our payloads on the right side. And that's why we're using a framework, so that we only have to write the exploits. We can reuse the payloads. And it works like this. If I search for the one I just created, I said that the capability is arbitrary file upload. And if I select this one, it is loaded into the framework, and the framework knows automatically that some of the payload is no longer useful. Lucky for me, WebShell has a delivery method of arbitrary file upload. I'll just load that. And the framework says we're good to go. It will also let us set the file name. Let's do filename.xml. And I should be able to just hit Control-R to run this, but let me copy this one so I can continue from the command line. So, at least it says it is working. Oh, actually, let me copy this and see what happened. So we're not expecting the code to execute, right? Because the file is still called .xml. But we have another problem. Because this is a 404 error. And why is that? Well, if we go back and have a look here, and I scroll up, we can see that we have the base name set here. We can inject the file name, but base name is not working the way we expect here. According to the documentation, it is actually stripping away the suffix. It is not enforcing it. Let's do this again. Let's copy this, quit, Is it big enough? I can make it a little bit bigger. Oops. And if I do file name, .php, .xml, and .xml is stripped away, we're left with a file called filename.php, at least at that point in time. So if we run this again, and I copy this without the XML part, and I go back here, do you think we have code execution? We still have a 404. I'll tell you why. We still have a 404 because of the pagination. So if we take a look again, I put this aside, we can see that we have pagination, and that is enforced. Where is it? Yeah, so XML is the doc name concatenated with underscore and the pagination, and that breaks things for us. If I go back here and I add underscore and the first page, we can see that we actually can inject the code to the web server, but we did not get code execution. And that's not really useful. So we still have a problem. We need to get rid of the underscore one part of the file name, otherwise it will not execute. So I have another question for you. Do we need pagination? The null byte guy? No, we don't need pagination. We don't care if their pagination is working. We just care if our file is executed. Let's go back here, scroll down, and let's tell the application that the page number is .php. We can do this a little bit more pretty. We can actually tell this one that we don't need the extension from this part. So we can strip, if I can type. So we can delete the PHP ending from here. We can add it back down here. I did a typo? Thank you very much. Saved me some time there. rstrip. Oh, I did another error. Let's scroll down and let's update this part as well. So we tell the framework that the real location is now filename underscore .php. We should be good to go. We no longer need this part because the default of payload.php should be enough, and make sure it's against localhost. And they at least tell us that we have a web shell at this location. Let's have a look. It's not a web shell, but it's PHP executing. Okay, so we can fix this because we're inside a framework, and this is how fast it goes. Let's just delete the PHP and tell the framework we instead want the instruction. So the instruction is passed to the exploit via the payload, and it's actually just the file content for arbitrary file upload. So I'll just swap it out for the instruction. I should be able to run it again. It's the same URL, so I should be able to just update this, and if I didn't screw this up, we have a shell. A working shell. Let's go back here. Yeah. We're now a push of a button from disaster, just as usual. But we're not finished yet. So this is just half the fun. It's not half the time, don't worry, but it's half the fun. Let me be real careful now. Let's go back here. Where are we? Why did I cap this at 50? It was a number completely chosen by random. So we have, if we stretch it, we have remote code execution in the Canadian bank supply chain. What could possibly go wrong? Nothing. It's correct. Well, something could possibly go wrong. And if you like what I'm doing, please come and let me know. Come and talk to me. Come and have a chat with me afterwards. I'll be here for the party. I'll probably be in the bar selling blank checks issued by some random Canadian bank. Thank you very much. That was all I got. Sorry to disappoint. Do we have questions? No? No? No question. Thank you very much. I'll leave.
No, there has to be questions. Are you so scared? Your domain wasn't on the list. Was it though? Any domain on the list? That would be so funny if we were.
Yeah.
That guy is mine.
Point it at securityfest.com.
Don't do that. We've been through this.
The framework you're using, did you write that or is that like commercially available?
Yeah, I wrote it.
Nice.
I wrote it. It's on my GitHub. You can use it. Also, all the exploits is on my GitHub.
Perfect.
Security Fest takes no responsibility if else or you visit GitHub and download the repo.
Don't hack anybody without consent and all that stuff.
Thank you so much. Any more questions? Come on.
Any more? We got time for one more, I think. We got one over here.
Where?
In the second row.
At least echo hello on the
That's more of a comment than a question. Okay, I think anything else, find him at the bar. We might want to take this offline. All right. Thank you so much, Emil.
Thank you very much.